In item 1 of this first exam in statics, we're asked to draw a properly labeled free body diagram of this bracket arm CEF of this machine. We're asked to do it in the simplest form, and that means that when we pull it apart away from the rest of the structure, we have to recognize how it's connected. At E, we're going to pull a pin, we're going to have two components, a horizontal and a vertical. And then likewise at C, when we pull that pin, we will again have two components, a vertical and a horizontal. If that was all it were asking us to do, then we'd be done. However, it asks us to do this also in its simplest form. So that means that when we go back up and look at the original situation, we see that member ED, when we were to pull it off, it is pin connected top and bottom, and because of that, with no other forces, that means we know that this is a two-force member, because if the forces that were not along the longitudinal axis or anything other than 0, that member would spin. So those have got to be 0. And if that were the only part of this story, then we'd be done as well. However, we got to keep thinking and looking at what's going on here. And that is that we now then have EY, we've got the applied force F of 150 newtons, but over here at X and Y, or excuse me, at point C, we've got two forces that will resolve into a single force. That means that ultimately this is a three-force member, and that means that all three forces then must be concurrent. So if we were to take the lines of actions of the forces, all of them have to pass through a common point. And since the 150 Newton force and EY intersect right down here at some new point, we'll call it F prime, then we can draw a line between that point and point C, and the resultant of the forces at C, CX, and CY must resolve themselves ultimately to be along that line of action. And that then ultimately is our free body diagram in its simplest form.